Hi, my name is Muhammad Rehan Hashmi bin Muhammad Zamani from CDCS 1432B, taking MAT 183.
My name is Raja Muhammad Khairul Hazim bin Raja Samsul, and I'm from CDCS 143 2B and taking MAT 183 Calculus.
My name is Shuro Iskandar bin Sa'ud Kharazmi. I'm from CDCS 143 and taking MAT 183.
Introduction. What is differentiation? Differentiation refers to the concept of differential calculus as a concern about how one quantity changed in relation to another quantity. The definition of derivative can be approached in two different ways that are interpretation of tangent line and rate of changes. Differentiation is a method of finding the derivative of a function. Differentiation is a process in maths where we find the instantaneous rate of change in function based on one of its variables. Simply put, differentiation in calculus is the process of finding the rate of change or slope of a function at any point. It tells you how steep a curve is. Question 1. Explain the meaning of differentiation and what are the techniques of differentiation. So, differentiation. A tangent line to the curve y equals to fx at a given point AFA is a straight line that touches the curve at that point. The equation for the tangent line is given by y minus y base equals to mx minus x base, or y equals to mx plus c, where the slope m is given by m is equal to limit h nearing 0 f a plus h minus f a divided by h. The derivative of a function can be defined as either f prime x or dy dx as long as both are derived with respect to x. So for example, we are given y equals to x squared plus 1 at 0.25. As we can see, we just replace the x value with the point, and then we place the equation with the formula given, and then we can use the answer that was given into the equation of tangent line to find the slope. So currently there are six types. How many techniques are there? Currently there are six. So the first one is the sum and difference rule. What is the sum and difference rules? So basically, if you have two functions given that are either plus or minus, you derive both the functions and then you plus or minus the results of both the derived functions, which will result. For example, you have x plus x to the power 3, which will become 1 plus 3x to the power of 2 once derived. The product rule is if you are given two functions that are needed to be times with each other, so they are needed to be multiplied with each other. So first you would need to label the two equations as u and v. You would need to derive both the equations by itself, u prime and v prime, and then you would have to use the formula u prime times v plus u times v prime. As the example given here, x squared times the bracket of x plus 3, where you are given where you need to label u and v, derive both the both the functions, and then equate them both by using the product rule. The last one is the quotient rule. It's similar to the product rule. The only difference is you are using it for a multiplication, pardon me, with the division, and the formula given is pardon me, v times u prime minus u times v prime divided by v squared. So as the example given here, you are given x squared over x plus 1, which after by implementing the formula, you get the answer, um, x squared plus 2x divided by x plus 1 squared.
And here, the fourth technique of differentiation, the chain rule. The rule of the chain rule is if u is differentiable at a point x and y is differentiable at point u, the chain rule says that dy over dx equal to dy over du multiplied by du over dx. This is called Leibniz notation, and here is the example of the chain rule. And for the fifth technique, the implicit differentiation, the procedure for implicit differentiation for step 1 is differentiate both sides of the implicit function with respect to x. Step 2, allocate the terms with dy dx on one side of the equation. Step 3, factor out dy dx. And step 4, solve for dy dx. And here is the example when we use step 1, step 2, step 3 and step 4.
Okay, for now
I will tell you about linear approximation and differential. Okay, that is a procedure for linear approximation and differential. Okay, now I want go to the step 1. You need to identify fx, and step 2, differentiate fx to compute f prime x, and step 3, determine value of x and x naught, then compute the change of value x delta x equal to x minus x naught. For the step 4, compute value of fx naught and f prime x naught. For the step 5, evaluate the estimation value of the function by using linear approximation formula. F x naught plus delta x approximation equal f x naught plus f prime x naught multiply delta x. Okay, now we can look at the example.
Question 2. Find dy dx for the following functions. A. Y is equals to ln 3x squared sec to the power of 2x plus 2. So this is the product rule where we have to label the first function as u and the second as v. We will need to derive both the functions, and because this is the product rule, we'll be using u v prime plus v u prime, in which case once we have replaced the values, we will get ln to the, 3x squared times 2 sec to the power of 2x plus 2 tan x plus 2 plus sec to the power of 2x plus 2 times 2 over x, and then we after multiplying it, we can simplify it as the answer that's given. So for b, y equals to e to the power of 4x plus 2 divided by cos x. Same thing, we take the top function and the bottom function, label them as u and v respectively, derive the both two functions, and then implement it in the quotient rule formula: v u prime minus u v prime divided by v squared, and then afterwards we will receive your answer for e to the power of 4x cos x plus e 4 to the power of 4x sin x plus 2x divided by cos to the power of 2x.
Here the question 3. Given y equal to ln 2x squared plus 3 exponent power of x plus cos 3x to the power of 5. Find dy dx using chain rule. Here the solution of question 3. First, we declare that u equal to ln 2x squared plus 3 exponent to the power of x plus cos 3x. And second, we declare y equal to u to the power of 5. And we differentiate u and differentiate y into du over ds and y into dy over du. And we substitute the value into the formula dy over ds equal to dy over du multiplied by du over ds, and get the answer of 10 over x plus 15 exponent to the power of x minus 15 sine 3x open bracket ln 2x squared plus 3 exponent to the power of x plus cos 3x to the power of 4. Here the question 4. Given y squared multiplied by ln 3x minus by exponent to the power of 2x plus 1 minus tan 4y equal to 0. Find dy dx using implicit differentiation. Based on the solution of question 4, first, we use product rule to calculate the y squared multiplied by ln 3x. And we get y squared over x plus 2y multiplied by ln 3x dy dx. After that, we calculate all of it and get the answer equal to dy over dx equal to 2x multiplied by exponent to the power of 2x plus 1 minus y squared over 2xy multiplied by ln 3x minus 4x secant square 4y.
Okay, now let me discuss question 5. Use linear approximation to estimate the value of fourth root of 80.99 minus 2 over square root 80.99 correct to to 3 decimal places. And that is the question. So let me move to the solution. Okay, first we go to the step 1. F8 equal to 4th root of 8 minus 2 over square root 8 and equal to 8 power of 1 over 4 minus 2 8 power of negative 1 over 2. Okay, for step 2, we do f8 to f prime 8 and f prime 8 equal to 1 over 4 8 power of negative 3 over 4 plus 8 negative 3 over 2. Okay, for step 3, we take x from the question and x equal to 80.99 and x naught is 81 and delta x is equal to x minus x naught equal to 80.99 minus 81 and equal to negative 0.01. Okay.
And the conclusion is, differentiation is a key component in understanding the behavior and characteristic of a slope. Differentiation tells you how fast something is changing at any point. It's the math behind slope motion and optimization, which is essential for understanding change in science, economy, and beyond.